In this video, I'll show you how to find the side of a triangle using the trig ratios. It should help you with exercise 10A.1. The first thing you should do before you start using your calculator to solve these problems is to check that it's in degree mode. On your calculator, right beside the blue second function button, you should see a button called Mode. Press the button, and then the third option down says radian or degree. You need to make sure that the black box has selected degree. So go over to degree if it hasn't and hit enter, and then you should be in degree mode. Degree measures the degrees of a triangle, and that's how we're measuring angles here. There's another way to measure angles that the extended course will learn later called radians, but we need to make sure for the beginning here that everybody's in degrees. Okay, then you can do second function mode to quit. So the blue button to get back to the regular screen. So first the blue button and then mode again with where it says quit in blue on top of it, and then you're back to your regular screen. Okay, we're now going to use the trig ratios that we learned to figure out what the lengths of sides are that we don't know. So the first thing we need to do is label the sides of the triangle with the sides according to the angle that we're looking at. Always start with the hypotenuse. It's the one across from the right angle, the longest side. So this is the hypotenuse. And then here's the angle, 70 degrees, that we're looking at. So the leg that is touching that angle is the adjacent, and the side across from it is the opposite. Okay, and that orientation will help us to find the right ratio and get the right answer. So the thing I want to know is the opposite side, and the side I already know is the hypotenuse side. So I go through SOHCAHTOA and figure out which of the ratios involves the opposite and the hypotenuse. So this is opposite hypotenuse, adjacent hypotenuse, and opposite adjacent. So sine is the one I want because that involves the side I'm looking for and the side that I know. I don't want any of the ratios with the adjacent because I don't care about the adjacent, I want to find it out, and I don't know it either. So this is the one I want. So I'm going to set up the equation with the sine ratio. So I find out the sine ratio for 70 degrees, and then I know that's going to be equal to the opposite side, which in my case is x, divided by the hypotenuse, the length of the hypotenuse, which in my case is 10 centimeters. I can leave off the units for the workings here. So to find x, I'm going to multiply both sides by 10, and multiply this side by 10. We'll multiply numbers by trig functions, then we can just write them next to it, just like bits of algebra, even though trig functions are not like regular algebra. So this 10 sine 70 degrees means 10 multiplied by the sine of 70 degrees. And on this side, that's equal to x. From here, I need my calculator. I'm going to type in 10 times, and then I have to press the sine button. It's right above the comma, which is right above the 7. And the sine button will automatically put a bracket out for you. And then you type in 70. And ideally you put an end of bracket, although with a simple equation like this, your calculator puts it in for you. And if you just press enter without the bracket, it should work out. Okay, then press the equal sign, and your display should read 9 point. You can give this a try while we're doing it here together. Pause the video and go get your calculator if you haven't already. Okay, you should get 9.3969, and then it goes on forever. The trig ratios are usually not rational numbers. They're usually repeating non-ending decimals, irrational. So we have to round it off somewhere. And in math, we usually do 3 significant figures, but in this one, since I was only given two figures over here, I'm just going to round it off to 1 decimal place. So this will be 9.4, and now I look at units. It was the length of this side, so I use the same units as in the problem, in this case, centimeters. So the length of x, if this is 70 degrees is going to be 9.4 centimeters. This isn't to scale, so probably this is not quite 70 degrees, it's a little less, and then this is actually a little shorter, but if it were 70 degrees, then that would be my answer. I've drawn another example. Sorry for the roughness of it. It's hard to draw straight lines in this program. It's a right angle triangle, and here I've got 35 degrees. I've got this side known. Here's my right angle. Remember, trig ratios so far only apply to right angle triangles, so there's always going to be a right angle. And again, I start by labeling the sides of the triangle. So across from the right angle, x is my hypotenuse. With the angle I'm looking at here, this is the adjacent, and the side across from here is the opposite. Okay, it can be in any orientation, so you have to use what we know about them to figure out what's what. I'm going to solve for x first, and so what I know is the adjacent, and what I'm looking for is the hypotenuse. So I go through my SOHCAHTOA and look for which ratio involves the adjacent side and the hypotenuse, and that's this one here. So this is going to be a cosine ratio. So I set up cosine of 35 degrees and make that equal to the adjacent side. That's 7.2 divided by the hypotenuse. That's x. Here I see that this is a bit of a different calculation because the side that I'm looking for is in the denominator of the ratio. In this first example, it was in the numerator, so I can't just multiply by 7.2 and get the answer. I first have to multiply by x on both sides to get it out of the denominator. So I get x cosine 35 is equal to 7.2. And now I can solve for x, but instead of dividing by a number here, I'm going to divide both sides by cosine 35 degrees. Cosine, you can't divide by cosine itself, but finding the cosine ratio of 35 degrees will just give you a number, so it's okay to divide by the whole cosine phrase, so to speak. Okay, so we can divide by cosine 35 degrees, but I can't just divide by cosine and get rid of that. I can't do x times 35. I actually have to divide by the whole function. And then in my calculator, I can get the answer. X is going to be equal to, because that cancels, of course, just like the x's here canceled. X is going to be equal to 7.2, and then I do divided. And now always start with a bracket. Whenever you're dividing by something, it's good habits to put in brackets because you want the whole denominator, not just part of it, to be divided. And then I type in the button cosine. The calculator automatically gives me a bracket when I do the cosine. So this is the button. And then the bracket comes up and I punch in 35, and now I have to close all my brackets. I close the first bracket for the cosine function, and I close the next bracket for my dividing by function, and then the equal sign. And when I type that in, I get 8.789577 on and on and on, and I round it off to 1 decimal place, since 7.2 was to 1 decimal place, and get 8.8. And last step, look at units. 7.2 is in meters, so the hypotenuse is also going to be in meters. And I can also see I must have done something, I hope I did it correctly, because the hypotenuse is longer than 7.2. That seems reasonable, it should be. So that's my answer. Okay, one last example. We're going to solve for y on this triangle, and that is the opposite side. Again, I go back to the thing I was given. 8.8 is rounded off, so I'm going to use the original data that was given instead of the calculated data. So I've got opposite and adjacent. And I go through the ratios and find tangent is the opposite and the adjacent side, OA. So I set up the ratio with tangent. Tangent is still 35 degrees, since that's the angle I related all the sides to. And tangent is equal to the opposite first. So I go y over the adjacent, which is 7.2. And there again I have the easier format. The thing I want is in the numerator already, so I can multiply both sides by 7.2. That's a 2. And this one times 7.2 and I get 7.2 times tangent of 35 equals y. And putting that into your calculator the same way we did before, we get y equals 5.04 or something or other, and so we can round that off to 5.0 meters. Again, to 1 decimal place. Okay, you're ready to try the exercise 10A.1.